Must subscribe at UK Experiments.
To know if the crystals of salts are really dry, let's perform a quick experiment. All we would need for this experiment is a burner, a test tube and a test tube holder. We would also need a few crystals of copper sulfate. Before we begin our experiment, could you tell me the color of the crystals? Yes, it's blue. The crystals look dry, don't they? But are they really dry? Let's find out. Now let's add these crystals in this dry test tube and heat it. What do you notice after some time? You notice that the color of the crystals turn grayish white. And did you observe the water droplets on the test tube? Why does this happen? It's because when copper sulfate is heated, it loses its water molecules. And that's why it turns grayish white in color. When it's dry, it's referred to as anhydrous copper sulfate. And what do you think will happen when we add water to it again? After adding water to anhydrous copper sulfate, it becomes blue again. The chemical formula for hydrated copper sulfate is CuSO4.5H2O. Yes, there are 5 water molecules you can see. This water is called the water of crystallization. Water of crystallization is the fixed number of water molecules present in one formula unit of a salt. So we can say that 5 water molecules are present in one formula unit of copper sulfate. And when heated, it loses its water molecules. Another example is that of ferrous sulfate. It has a green color due to the presence of 7 water molecules in it. So though the crystals look dry, they aren't really dry. Another salt which possesses water of crystallization is gypsum. It's a hydrated salt of calcium and its chemical formula is CaSO4.2H2O. What is it used for? When we heat gypsum at 373 Kelvin, it loses its water molecules to give us plaster of Paris. Have you heard of plaster of Paris before? Yes, it's a substance which doctors use as a support for fractured bones. It's also used in the construction industry and in making casts for statues, and also making designer false ceilings. Its chemical name is calcium sulfate hemihydrate and its chemical formula is this: CaSO4 and half a molecule of water. After addition of water, plaster of Paris is again converted into gypsum. Okay, are you wondering how we are able to see just half a water molecule here? Is that possible? It's written like this because 2 formula units of calcium sulfate share 1 water molecule. And why do you think it's called plaster of Paris? Does it have anything to do with the city named Paris in France? Plaster of Paris was first made many years ago and has been used by ancient Egyptian and Roman civilizations. However, it wasn't used on a large scale until the 17th century, when it was required to be used in almost all the construction in Paris. In the year 1666, a fire raged across London, destroying many parts of it. In its aftermath, the King of France ordered that all walls made of wood in Paris be immediately covered with plaster as a protection against such fires. This resulted in large-scale mining of gypsum, which was available around Paris in huge quantities. Thus, during the early 18th century, Paris became the center of plaster production, and hence the name Plaster of Paris.